Hey everyone, here's a little grade school math rant. Let's look at the expression 10 divided by 5. The way I was taught to conceptualize this is that we are taking 10 and we're splitting it up into 5 equal parts. So we're doing something like this, and then the size of each of these parts is our answer, in this case 2. But there's another way to think about what we're doing here, which is that we are counting to 10 by 5s. So we count up to 5, and that gets us 1, and then we count by another 5, and that gets us to 2. This second way of conceptualizing division was never explicitly taught to me. However, it did kind of creep in when we started doing more complex calculations. So when we learned to do something like 250 divided by 3, we were taught long division, where you set it up like this, and you start by looking at the first digit and asking yourself, how many times does 3 go into 2? This language of go into 2 sort of maps onto this way of thinking about division, where we are counting by the second number. So if we just run through this real quick, you get 3 times 0 is 0, so you get 2 here, bring down the 5. We know how this goes. 3 goes into 25 8 times, so that's 24. Subtract that off, you get 1. Bring down the 0. 3 goes into 10 3 times, and then you finally subtract that off. So your answer here is 83 remainder 1. So this is using that second way of thinking about division, but again, I never felt like these two concepts were made totally clear. And even our language, we talk about dividing, this clearly favors this first way of thinking about the operation. So I would propose we actually start using 2 different verbs to talk about division in 2 ways. And we can also use separate symbols to write these 2 ways out. So the first way of writing it out is the familiar way, and I would read this as 10 by 5, or said more explicitly, count to 10 by 5s. But another way of writing it would be this: split 10 into 5 parts. Make 5 parts of 10. One nice property of writing these out in 2 different ways is it maps on nicely to thinking about division as undoing multiplication. So there are 2 ways to write 2 times 5. You can write it as I just said it, 2 times 5, or you can write it as 5 times 2. And we are taught that these are equivalent. They'll always give you the same answer. But how do we think about undoing these operations? So how would you undo 2 times 5 to get back to 2? Well, what you're doing here is you're making 2 copies of 5 and then adding those together. So if you want to see how many copies you made, it's very natural to simply count by 5. So 2 times 5 by 5 is 2. Now, how about undoing 5 times 2? How do we get back to the thing we made 5 copies of? Well, if we made 5 copies of it, we know that we can split it by 5. So 5 splits 5 times 2 is 2. Looking back at this example we worked through using our new vocabulary, long division is sort of the 250 by 3 way of working through the problem. So how can we work through the problem in the 3 splits 250 kind of way? Well, let's just ask ourselves, when you do 3 splits of 250, what's the answer? And the truth is, I don't know what the answer is, but I can easily approximate it by doing something I do know, which is 3 splits of 300, which is of course 100. And so we already have a very quick approximation, which is our answer should be a bit less than 100. But we can get closer. So to do this approximation, I increase the real number by 50. Well, I don't know what 3 splits of 50 would be, but I do know what 3 splits of 60 would be. That is, of course, 20. So this tells us that our first approximation overshot the real number by a bit less than 20. So we are already pretty close after just 2 approximations. We already know that the real answer should be 80 plus a small number, which is, of course, what we get when we do the explicit calculation. So this is why I think having these 2 models of division would be really helpful for making it more concrete. If you enjoyed this rant and you want to hear more rants in the future, please subscribe, and I will see you next time.